Hi everybody, welcome back to the TETRIX RoboBench video series. This is Tim and we are ready for activity number 5 of our getting started activities for the TETRIX PRIZM programming guide. So we've talked about a lot of things in our getting started activities. We blinked our red LED light, we moved our DC motor, we moved our servo. We talked about sensors with the line finder sensor from Grove, and now we're going to talk about sensors in regards to the ultrasonic sensor. This is the ultrasonic sensor that comes from Grove that we include with our PRIZM programmable set. Ultrasonic sensors are basically work off the idea of sending out a pulse of sound. It's in the ultrasonic range. We can't hear it with the human ear. That's why it's called ultrasonic sensor. But the idea is it sends out a pulse of sound and listens for the bounce back or the return of that sound wave as it interacts with objects along its path. So because we know the speed of sound, we can actually use that to determine distance. So a lot of people call these a distance sensor, but basically, again, it's working off of sound. So that's kind of how that sensor works. Let's figure out what we need. So let's gather up our parts. We have to have, obviously, our PRIZM microcontroller. We need to have that. We need to have our wiring harness, charged battery, our USB cable, and then last but not least, our ultrasonic sensor and cable. So let's go ahead and hook that up real quick. We're going to put it into digital port number 3. Again, this is keyed, so we can only put it in one way. We're going to make that firm connection. We're going to go ahead and plug in our USB. So it is all ready to go when we get ready to fire it up. And we are connected. We made all our connections. So now we're ready to open our sketch. So if we go to our software, we're going to go ahead and launch the Arduino software. And as we open that up, again, if you've got a sketch that you want to save, remember to go ahead and save that. And then we can go and open up our example by going to File, Examples, going down to the TETRIX PRIZM, and then getting started activity number 5, Intro to Ultrasonic. Excuse me. The window's going to go ahead and come up here in a minute. When it does, I'm going to make this a little bit bigger so that we have plenty of room to talk about the new stuff in this particular activity. So let's go ahead and look at some of the new things that we have in this particular sketch as far as building our knowledge base. So one of the first things that we want to talk about is we're going to show a new tool that takes advantage of the sensors specifically and being able to look at those in real time, and that is the serial monitor. This becomes a useful tool when you're having to figure out, okay, what's my data from my sensor and how do I need to integrate that into my programming with my building so I can use that for intelligent decisions. So this serial monitor, we can open that up and it will give us live interactive data from our sensor in real time as long as I have a connection between my PRIZM and my computer. So that's an important thing to remember when we begin this. So let's go ahead and let's execute the code. We're going to go back into our application. We're going to go up and we're going to verify our code after I turn it on. Obviously, I need to turn my PRIZM on. Got my blue light, got my connections, got my solid green light there waiting for me to upload the code, and I've got my sensor attached. So I'm going to go ahead, verify my code, and press that little verify button. It's going to quickly tell us whether or not the code is correct. As long as I don't get any error messages, I can go ahead and upload. And again, I should see some data lights going on as it sends the code over to the PRIZM. Once it does that, and I've got a green light here, again, we're going to use the serial monitor here, so we need to leave the connection between the two because we want data to come back from the PRIZM to the computer. I have to have something to read that from, so I'm going to actually open up my serial monitor over here in the upper right hand corner of my code window, my sketch window. It's going to open this serial monitor, and I am ready to execute. So I'm going to actually, what's going to happen according to my comments is that I am going to execute the code, and this is going to read the sensor in centimeters and pass that information back to the serial monitor. So I'm going to execute this, pressing my green button. My serial monitor is actually reading information now, and as I move my hand in front of that, I see that information changing. I can actually move my hand very close, and it moves down to 2 centimeters, and actually, as I move it away, I'm getting a different distance. I can point it open sky or off in the distance. You see the information changing. I can point it down at the table, and I get different information as I move it closer and closer. The other thing I want you to see is information you see is data is transmitting back from the prism to the computer. I have a data light moving back and forth, so that's important to see as well. I'm going to stop this just for a moment. And let's talk a bit about what's basically new in this particular activity that we want to take advantage of. So several things going on here that we want to make sure that we talk about as part of our moving forward section. And the first one that we want to look at I'm going to close my serial monitor just for a minute so we get it, or I'll just move it out of the way. First thing we want to look about is this serial begin command that's in the setup. This is something that we only need to execute one time. The important thing about this is basically it's saying that you're going to use the serial monitor and set the baud rate. The baud rate is basically how fast the serial monitor will update information and talk as far as look at the sensor. So that baud rate is important in order to make sure, and we can change that, but we need to make sure that we tell the computer what the baud rate should be at the beginning when we configure that. And we only need to do that one time, so it's in the setup portion. Now, when we look down into our loop on our activity, there's a couple things. We have serial.print, and this is a function that basically is going to say, I want you to record the information onto our serial monitor. And it's a continuous a function that says I want you to continually record, and what you're recording is in the parentheses, and this is prism.read sensor in centimeters, cm. So this is a new command for us, and basically this is just reading the sensor. Again, we can change what port it's in, but we can see right now we have that in port number 3. So again, we're telling it to print to the serial monitor, and what we're printing is the data coming from the ultrasonic sensor. The other new thing is serial.print line. There is an option to manually, in order to clarify the data that we're printing, we can actually add a word. And in this case, that's what we're doing. We're saying serial.print line, and what we want to print, we actually are manually inputting inside the parentheses, in this case centimeters, because we want to add that to the data that we're reading so that it makes sense when we actually look at the monitor. We can physically interpret that because we've added the definition of centimeters after the actual value that the sensor is giving us. And the last thing in the loop obviously is a delay. Again, we want to control how fast it reads that, how fast it prints. If we let it go too fast, it's going to be actually entering information so fast we would not be able to see it. So we want to make sure we visually can track what the computer is capable of printing. That's why we have the delay. So let's go ahead. I'm going to execute that again just so we can see what that really means in the serial monitor. And you can see as I look at that again, we're getting information that changes as I move my hand in front of the ultrasonic sensor. So that would be a good test to see how our build is interacting with our sensor. And I can stop that by pressing the red button. So let's talk a little bit more about what that means as far as real-world connections. Ultrasonic sensors, again, as distance sensors, can be used in a lot of ways. If you think about some of the old war movies that we had, the sonar when the submarine was in the ocean and looking for enemies and things, that's basically sending out a sound of pulse, or pulse of sound, and waiting for the bounce back, and then being able to read distance from that. So that's an example of how an ultrasonic might be used in real world. The other thing that it might be used is in medical technology, things like that. But STEM connections, we can look at that. There's terminology that is involved with ultrasonic, amplitude, frequency, crest, trough, those type of things. The actual way sounds are waves and how they reflect off of objects and different types of objects, different shapes. Technology, we can talk about frequency, we can talk about sound digitation, we can, from a technology standpoint, talk about the applications of what those sonic measurements might be. And then there's math applications as well, as far as maybe an inverse square law, things like that, as far as how it reacts to measuring that sound coming back. So those are some of the connections on how this would interact with the real world and our STEM. For our hacking the code activity, again, going back to the open-ended part of this, we want you to try and recreate that from scratch. Remember the things like the code library in the back, copy and paste if you need some help by that. From that, but also remember what we've applied in some of the earlier getting started activities. How could we use this with a motor, maybe to turn the motor on and off as a switch when it comes close to things. Again, with the LED, maybe we could flash an LED based on distance. So think about some of those things and be creative. Test with how some of these might react to different kinds of objects. Does it react different to a hard object versus my hand, or different shaped objects? Explore a little bit of that. Have fun. Remember that if you need help, there's the appendix is in the back for additional information on how these things all work. So I hope you found that informational. I hope you found it inspirational on some of the new things that you want to do. Remember, have fun, build some robots, come back and we'll do some more.